Hello and welcome to Sustainable City Network's presentation of a webcast that will demonstrate how you can extend your resurfacing budget by as much as 40% with hot-in-place asphalt recycling. So in a moment we're going to hear from Patrick Faster. He's National Sales Director at Gallagher Asphalt Corporation, the company that pioneered the hot-in-place recycling process. My name is Randy Rogers. I'm Executive Editor of Sustainable City Network, publishers of the online trade magazine scitynetwork.com. We also publish a weekly email newsletter called The Inbox that goes out to about 25,000 local government subscribers every week. We have a quarterly print magazine called The Best of Sustainable City Network, and we also produce webinars like the one you're hearing, and we do trade shows and some other interactive content. Everything we do is specifically designed for municipal professionals and elected officials, and particularly those that are involved in the day-to-day challenge of building sustainability in their communities. We reach readers in all 50 states and throughout Canada, and our content, we strive to have it be quality and timely information on sustainability best practices, products, and services. So today we've got, we're really thrilled to have more than 200 registrants from cities and counties across the nation tuning in. Before we get started with our presentation, we want to get our audience involved a little bit, so we're going to take a brief poll. We're going to ask 3 questions. You're going to see them pop up on your screen, and we'd like you to quickly click on the appropriate responses, and then we'll show the results afterwards. So the first question is, on your roads under management, using a scale of 1 to 100, what is your average payment condition index, or your PCI rating? Is that 40 or less, 41 to 60, 61 to 80, 81 or above? And I'll give you a few moments here to click on the appropriate answer, and then we will go on to the next one. Okay, our next question is, with your typical annual road budget, what percentage of your total roads are you able to resurface? 30%, 20%, 10%, or less than 10%? Okay, now we'll move on to our third question, which is, other than milling, what forms of asphalt recycling have you used? Your choices are hot-in-place recycling, cold-in-place recycling, full-depth reclamation, or none of the above. And again, we will show the results of this poll after our presentation. And during the presentation, if you'd like to enter questions, we're going to have, you can enter them in the question box that's provided there in your control panel. And Patrick will get to as many of those at the end of the presentation as possible. But if you know, your question doesn't get answered during the presentation, you're going to get a survey after the presentation that you'll have the opportunity to fill out. So now I'd like to introduce our speaker. Patrick Faster is National Sales Director for Gallagher Asphalt Corporation. He earned his MBA at the University of Wisconsin, followed by more than 20 years of experience in the highway construction business. He's an active member of the National Association of County Engineers. He is Vice President and sits on the Board of Directors with the Asphalt Recycling and Reclaiming Association. And he's a member of the Pavement Preservation Expert Task Group, where he is a contractor liaison to the Federal Highway Administration. Currently, Patrick leads the recycling division of Gallagher Asphalt out of Chicago, Illinois. Gallagher Asphalt was founded in 1928, and it's paved and resurfaced hundreds of thousands of miles under some of the most demanding roadway conditions. The company pioneered the hot-in-place process, which turns your existing road into an asset that you can recycle on-site, consuming approximately 30 to 35% less energy than conventional resurfacing. So now not only can you resurface more miles with the same budget, but now you can help your community reduce its greenhouse gas emissions in the process. So without further ado, I'm going to turn things over to Patrick. And Patrick, go ahead and take it away.
Randy, thank you. I appreciate the warm intro. Anybody who's out there listening, which is very odd for me, I do a fair amount of public speaking, but it's usually from a podium overseeing an audience, so I can see at least who's going to throw stuff at me or heckle. This is, as I said, anybody who knows me, this is a quantum leap. I'm afraid I'm going to hit a button here and disconnect the whole world. So if it's one or two of you that are listening, I appreciate your signing on, or if it's the 240 that he said he had, I appreciate you all signing on. We're going to talk about hot-in-place recycling. Before I do that, I'd like to cover just kind of a brief overview of recycling in general. We're going to keep everything, excuse me, at the 101 level. Nobody's going to walk out of here with a PhD. But I think, in all fairness, I should touch on recycling. We're going to talk specifically, as I said, about hot-in-place recycling. Cover some aspects of as to where you should use or consider using hot-in-place recycling, when you should use that in the life cycle of a roadway. Crunch some numbers on it. Compare hot-in-place recycling versus some conventional methodologies. And then perhaps have some questions. And there again, that's a little odd for me. I'm normally usually getting questions from, during the presentation as well as at end, which is a face-to-face. So it's kind of a new experience for me. But if I can get through it, I guess you all can get through it as well. Not to make this a commercial about Gallagher Asphalt, but I think it's important to know who someone's talking with. What kind of reference or background they have. So we'll keep this just a very brief part. Gallagher Asphalt in Chicago area, which is where I'm speaking from, is one of the largest and oldest asphalt producers in the state of Illinois. Been in business, for pushing the 90 years. The third generation. There's some fun facts in here, assuming that you're all seeing this. Relying on faith here a little bit. There's some active organizations that we're actively involved in, NAPA and MCAT, Illinois Road Builders, and so on and so forth. But a fairly well-respected old-line asphalt paving company out of the Chicago area. And usually the punchline I use when I'm introducing myself or speaking to audiences is that we've been building roads for about 85 years and recycling them for about 30. So that being said, one other area that I wanted to cover is one of our other divisions, Chicago Testing Labs. But in all likelihood is the oldest testing lab in the country, founded in 1912, and does full-line testing, highways and concrete and soils and so on and so forth. These are all available on our website, but that's in the host of Gallagher companies as well. I think you mentioned that Randy mentioned that I was actively involved in ARA. That's the Asphalt Recycling and Reclaiming Association. It's a couple 300 suppliers, contractors, and whatnots involved in some discipline or area of recycling. It's a national organization headquartered out of Annapolis. I happen to be on the board of directors and vice president, and I think in a couple of months I'm about to be president of the organization. What did Groucho Marx say? Any organization that would have me as vice president I don't want anything to do with, but enough said there. These are the 5 disciplines that ARA recognizes, and they are in sequential order. And when I said we'll do a brief overview of recycling, this is going to be that slide. That's how brief it is. But we often forget, and some of my colleagues from ARA and the guys in industries, we go around and promote recycling around the country at speaking engagements. We forget that when we step up to the podium that not everybody is up to speed with recycling. Some people have heard of cold or heard of soil and not sure what, when, where, or how. So the 30-second version would be, these are the 5 disciplines that are recognized by ARA, and they are sequential. And cold planing and milling has been around for a good long time. and that is the purest form and probably the oldest form, is milling the roadway off, milling the surface off and taking it back to the plant to batch with virgin, some percentage, depending on what agency or state you're from. It may vary as to the percentage amount you're able to use of wrap back and virgin mix. If you have a surface issue on a roadway, by surface issue, I'm going to identify that up to a depth of around 2 inches. You may consider, on a structurally sound road, hot in place recycling as a fix. If you have a problem that is typically going to equate to an older roadway that is deeper than the 2 inches, you have a more severe problem, still not a structural problem, but you want to work deeper than the typical 2-inch maximum hot in place depth, you may consider cold in place recycling. Cold in place recycling starts around 2.5 inches, and it'll run out about 5 or 5.5 inches. So there's the next set of fixes, if you will. If you've got some issues in your roadway, typically it's going to get into the stability of the roadway or structural issues that are deeper than that 5 or 5.5 inches. You're probably going to have to entertain or certainly should consider FDR or full depth reclamation. More times than not, when you're doing FDR, you're probably going to incorporate some level of soil stabilization. So if you've got a bad road, structurally gone, it's shot, FDR is a likely candidate for you. You may well be using some fly ash or lime or cement and do some soil stabilization underneath. The common denominator here with these 5 disciplines is reusing the existing material that you, and I'm guessing that I'm speaking to a lot of agency people, but you as the agency have bought and paid for the materials that constructed that roadway. In our organization, and anybody using common sense today, with the price of other raw materials, oil and aggregate, should be utilizing the materials that you already have title to. When I do a lot of speaking, again, where I can see the people, one of my punchlines is that this aggregate sat in a quarry for 450,000 years. We think it's good for another 10 or 12. And it's a little humorous, but it makes sense. Good aggregate is hard to find. Good clean aggregate is hard to find. Being in the Great Lakes area, I see a lot of surrounding states that have none and truck it or rail it a good long ways. So take a look at that roadway that you have out there. You have bought it, you paid for it, you've maintained it. The federal government now makes you inventory it under T21. Don't be so fast to give it up. The other item that it has on it is oil. In some cases, you may have well over 35 or 40% of the oil that was originally put on it. That's a good asset to have as well. So before you bring the miller out and haul it away and give it back to an asphalt producer, which we are one, you might want to rethink some things or look at some other disciplines. That being said, underneath within the hot in place recycling discipline, there's a couple sub-chapters here: surface recycling, remixing, and surface repaving. We're going to talk about surface recycling today. Surface repaving is very, very similar to that. If we have any questions, we'll let those come up. We've only got a limited time here, so we can't make everybody an expert on all methodologies. So there's the 3. Probably the most common in the country, the most economical, is the surface recycling, which I have to say under the same umbrella, and surface repaving would fall. There are probably more contractors out there doing that process than anything else at the moment. That can vary regionally. Back to the Gallagher asphalt side, where I'm going to make it a bit of a commercial. These are the 2 versions that we do, and that's exactly what I'm going to show you here today. The reheat method, which is the current generation or next generation in our minds of hot in place recycling, and the surface recycling. So we're going to walk down a little bit of history of the processes themselves. I think this is a great photo here. Again, I'm assuming you're all looking at the same photo. Where does it fit in? As a contractor, I'm going to put my Gallagher hat back on here. For 30-plus years, most of our business has come from the reconstruction side. And I'm going to run you through a drill here. But on the reconstruction side, I'm saying by comparison to a 3-inch mill and fill, which I think by all rights is considered reconstruction in probably 48 or the 50 states. But what we have seen and where the greatest growth has been, selfishly from a contractor standpoint, has been on the preventative maintenance side. And what we have seen is, rather than a total reconstruction, we may do hot in place recycling where on the reconstruction side it's getting recapped or surfaced treatment was 1.5 inches or 2 inches of asphalt, tighter budgets, more expensive raw materials, liquid AC, aggregate, so on and so forth. So they'll rehab the existing roadway with hot in place recycling, and then they put a less expensive surface treatment on it, like a chip seal or a micro or a slurry, or a 3/4 inch or ultra thin bonded wearing course, I think they refer to it as, but less expensive surface treatments because the budgets just aren't there. And again, one of the other lines I use all the time is when I'm directly speaking to agency people is that I say to those folks that you always have $100 worth of problems and about $65 to fix it. So you got to be looking outside the box. You got to be looking for a different fix, and so on and so forth. And this may well be suited for you. Ideally, from a textbook standpoint, where do you want to do hot in place recycling? Excuse me. The textbook would say our BARM, which is a production from ARRA, which is our basic asphalt recycling manual, would say you want to start entertaining the thought of hot in place recycling somewhere in the 5, 6, 7, 8 year range. That's in perfect conditions with normal budgets and reasonable asphalt prices. I don't know the last time that I worked on a 5, 6, 7, 8 year old asphalt road for hot in place. So in that regard, we continue to lower the bar, if you will. We are working on 9s and 10s and 11s and 12s, and we can do that. I say we, I'm referring to good asphalt hot in place recycling contractors as well, not just single Gallagher. You can look at an 8 or 9 or 10-year-old road depending on the customer's expectations. If we continue to lower a bar, there have to be some caveats again about what his expectations are. That's very, very important to us as a contractor and obviously to the agency as well. Let me run you a drill here real quick to show you on that reconstruction side what we have done historically, and then I'm going to move you through this time warp, if you will. There's a typical grind in overlay, and I think everybody has seen that and is aware of that and knows what that is, but let's run a quick drill here. And I guess they have it at a 2-inch here. So a typical 2-inch mill and fill is going to bring the grinder out in a whole bunch of trucks. All those grindings away. Bring the tack course back after you've taken your 2 inches off. Bring your leveling course back to the job site or trucks. Place your leveling course. Guess that would be more carbon footprint in there. Put a roller on it. Call your surface course back to the job site. Place that course. Put a roller on it. Put a stripe on it. And it's done. If you pay attention, whether there's 2 people or 200 people out there, you'll find there's a little bit of humor laced through this whole thing. So I'll pause for a little laughter, although I can't hear it. Their standard methodology, a mill and fill, been around for a long time. It will be around for a good time longer. There comes a time in a roadway's life that it hasn't got the attention and it needs to be ground out and taken away. We've got a couple of choices here. Let's talk about surface method or heater scarification, as it's referred to, and I'll compare that back to the mill and fill that we just saw. I always heard that a good speaker should not read to his audience, so let me read this to you. Actually, go ahead and read that yourself. It essentially says that instead of milling that pavement out, we are going to rehabilitate it in place and essentially make it a leveling course, make it ready to receive a new surface course. That's how we're going to do it here. This is one of Gallagher's particular machines. These are similar to other contractors across the country. This is what we call an urban train. This is typically working in urban environments, suburbans, and city areas. We do a fair amount of work. That probably 65 or 70% of our workload is in cities like Milwaukee and Chicago and St. Louis and Indianapolis and so on and so forth. So we're used to working in tight areas. So we have a shorter train. I don't even like actually using the word train. Train indicates something maybe 400, 500 foot long and closing lanes down and so on and so forth. This is a 2-tractor unit followed by a roller. Excluding the roller, it's 152 foot in length. And the first is a refractory line propane-fired oven, and that's all it is. It's just going down the road, somewhere in the vicinity of 8 to 15 foot a minute, and it's going to slowly reheat the pavement. That first oven is going to take it up, as it says in the top banner, at 180 or 200 degrees. The second oven is just a duplicate oven of the first one. We'll take that pavement temperature now up around 300, henceforth which it came, if you will. 300 degrees is the temperature that this material showed up as virgin asphalt when it was placed originally some years back. We've got 300 degree pavement. We are going to introduce the particular rejuvenating agent. May vary from contractor to contractor, but we are going to introduce rejuvenating agent to the pavement. This pavement has two problems. The two single largest problems that your pavement has is the lack of AC, or the UV rays have cooked the liquid out of this pavement and made it less flexible or brittle. So several years into it, as this AC cooks off, you start to see some reflective cracking. And reflective cracks are not attended to, and they become more severe. The pavement essentially then opens itself up. It opens itself up to take on moisture, and at the same time is losing some of the fines, which are very much a part of the matrix, or part of the mix that holds that matrix together of sand and various size aggregates, and the fines and the oil all come together to give you your density in your asphalt pavement. When those fines start coming out, that's typically the beginning of the end. Look at a 5 or 6 or 7-year-old road. Look over if it has a curb and gutter. Look what's laying in the pan. You see the fines laying in the pan, and that's not where they belong. They belong on the roadway. So those are the two most serious violations that happens over time to that pavement. We use, in this case, a polymer-modified rejuvenating agent, which my own lab people tell me will, in fact, make up for some percentage of the loss of those fines. We've already identified that we're putting the liquid back in it. We're using the polymer modification to offset some of the loss of fines. In this particular operation, we are going to put a set of steel forks or flexible tines after we have put that rejuvenating agent into the pavement, down into the pavement at a prescribed depth. He's in the up position here, I think, for the photo, but those typically can go into a pavement at up to around a 2-inch, and some jobs we've gotten 2 1/4 depth. Typically, we're running at 1.5 inches. We've identified from a previous slide that this particular process is going to rejuvenate what's there. We're rejuvenating the roadway, making it ready to receive a new surface course. So I just said a moment ago that we're typically working at 1.5 inches depth with these steel forks or tines. Is because the reason that we do that is because the last lift typically put on the road was 1.5 inches deep. We don't want to miss the larger level or binder aggregate with the surface when we bring that to the top. We want a good steady mix. So if the last lift was 1.5 inches, that's where we're going to work. If the last lift was 2 inches, that's where we're going to work. So we'll dictate that in every road that we look at, as any other hot and place contractor looks at, is different. You have to take everything on a case-by-case basis. I said those forks are in the up position. They're hydraulic down. They're spring-loaded. So if we run into any structures in the roadway, be it manholes or B-boxes or go-tos, those spring-loaded tines will just bounce over the top and then resume their prescribed depth and go on down the road. So we don't have to stop and finger for it and hand work. A little bit of hand work, but nothing dramatic. We don't stop the operation. There's an auger right behind the tines, full-width augers, giving the roadway a good mix, make sure that oil's in it. We can do some limited profiling with the road. You get too much crown, we can knock it out. You want a little bit more crown, we can put it back. We put more crown back. We're robbing Peter to pay Paul. The only material that we are introducing into this process is the liquid. So if you want more crown, we can do that, but we're going to take it from the shoulder, so you'll have to make it up on your finished pave. Behind the mixers is a conventional paving screed. He's carrying a head of material down the road, as would a conventional paver at a job site. He's getting fed by 6-wheelers or semis, and he's redistributing that the way it should be. Vibratory, heated, chase it with a roller. When that roller passes a driveway, passes a business entrance, passes a residence, it's open to traffic. The project isn't done with heater scarification, but the roadway is open to traffic. We're down now, one would have to assume, below 150 degrees where a roller shouldn't be on it. So my point here is utilization of flaggers on this project will be lane restriction and not lane closure. There's a big deal. I mean, I'm going to show you some numbers a little later that are going to justify the cost of hot in place over mill and fill, and that's without using user delays. If you threw user delays in there, it'd be astronomical. But we have minimal interruption to the motoring public. We don't have, again, lane closure. It's just restriction, and that's appreciated by all. We're finished with the hot in place recycling process, and now if it's here in the Midwest or it's here in our backyard, we may well come out and do the surface course of the paving, or as we move around, we usually leave that to the local paver. In the three instances, the three technologies under the hot in place heading with there was another process called surface repaving, and that's a turnkey operation. They don't have another paver come in and do that. But anyhow, the hot in place recycled asphalt is now ready, in this case, to receive a new surface course. If you remember that slide, where does it fit in? What we are seeing a lot more of that is budgetary driven is less expensive surface courses. So not everybody has the budget for an 1.5 or 2-inch overlay of hot mix. They may well go with a micro surface, a slurry surface. And that, I think, comes back to customer expectations. What are you looking for? You're obviously not going to get the longevity out of these less expensive surface treatments than you would from a structurally introduced product like asphalt at an 1.5 or 2 inches. But it may well fill your bill. It certainly will be bang for your dollar and get you to where you need to get to. And that's obviously going to depend from region to region as to what kind of life you get out of the less expensive. But they are very much part of the ball game now. Make no mistake about that. Chip seal is kind of an old country. We see a lot more chip seal. It seems to be every year after year after year. It's a good sell. It has although minimal, it does have some structural value. But chip seal is moving downtown. We have worked for the city of St. Louis County. They use a lot of chip seal right down on their main drags, main streets in town. It's quite a product if you get the right emulsion and the right rock. Let's move on. The series of, or the development of the heater scarification has evolved into what I would refer to the next generation of hot in place recycling. We happen to call ours a reheat method. You can go ahead and read this definition. There's a little different methodology here, and rather than read this to you, as I said before, I won't do. Let's walk you through the process. For years, people have asked us, why does it have to be covered up? Why does it have to be covered up? Because we think we're returning the road to a certain percentile. It's not a virgin mix design. There's things that happen to the road, and we feel better about it. I think there's longer life going to be gained off the roadway on the heater scarification with the surface treatment. This process, reheat, is going to retreat the road via heat, but will not, in fact, require a surface treatment of any sort. So this is where hot in place recycling has evolved to. We've been playing with the idea for a good number of years, and finally have gone ahead and put the equipment together that will do the job. The basic difference, I don't have a lot of pictures, I don't think, in this PowerPoint, but the basic difference with this unit is we are picking the roadway up and putting it into a drum. The hot in place asphalt heater scarification recycling is in situ. That aggregate actually never comes off the roadway. This process will, in fact, with a mow board, dial in at a prescribed depth of 1 inch or 2 or 3 and perhaps beyond. But again, since we're leaving a finished product, it's going to be dictated by the surface treatment that was last put out there. So if there was 1.5 inches, again, or 2 inches, that's the depth that this piece of equipment will work at. But rather than using the scarifiers of the times, it'll have a preheater. See if we can't get there. There's the 2 units in tandem. The preheater is a bit more state-of-the-art, a bit more efficient here. If you recall, our heater scarifier, our tractor trailers, pulling an oven deck down the roadway. They get one look at the roadway. If we want more heat, we've got to slow down, but that tractor trailer is going to give you one look at it. This is what I call our Zamboni machines, or they act more or behave more like a roller. They're hydrostatic transmissions. They're able to go up and back. So if we need more heat, or we want to have this preheater act like more than one unit, we simply dial in a heating pattern as much the same way you would a rolling pattern. So it's able to go up and back and make itself behave like a second unit or a third unit. I think that is beneficial. Less carbon footprint, less equipment, less fuel, less, and giving us the heat that we need. So we have a preheater out in front, just a little different configuration. That essentially, again, will take it up to that 180 or 200 degree level. Pretty good picture of it there, I guess. I don't have, appears to be a good picture of the drum. The preheater's out in front. Stay with me, Aaron. Go ahead. So anyhow, we've got the pavement that's softened. We've got 180 degrees. The process unit's going to come along. It has another oven unit on it. That's going to take it to the next 275, 300. Again, we're at the temperature where this material showed up when it was virgin. At 300 degrees, we can start the process. So I don't have the forks or the tines. I'm going to drop a moldboard or a blade down to that prescribed depth and feed this material into the mill, or a paddle wheel of sorts that's going to take this into the mixing drum. The mixing drum has heater elements. One of the issues, particularly early in the season or later in the season, particularly in the Great Lakes area, is heat loss. It doesn't take long. Even when you're a standard paving operation, you all know that it doesn't take long for the heat to come out of that pavement. The mixing drum here, which is similar to what's going on in the plant, which is outside the door behind me, has a heat element, and that's where the oil, and we've gone from, I didn't tell you before that the rejuvenating agent that we were using is an emulsion. I apologize. We have gone to an oil here for reasons, because this is asphalt pavement that we're going to leave in place. This is the finished product. But to compensate for that heat loss, the drum has reheat capabilities. It'll be in there a good long time. This time of the year, it's kind of a nasty day here in Chicago. It had tremendous heat loss. I'm not even interested that much in the heat gain if I can prevent the loss, and that's in fact what's going to go on this drum here. So the oil is injected in the drum. The heating element goes on in the drum, and then it's going to come out in a windrow. There's some good pictures, but it's going to come out in the windrow out the back side of the drum that will get augered across the mat, and the paver right behind that. I said I had limited pictures here. They get augered, the freshly rejuvenated material gets augered across the mat, and it gets fed to the paver, and the paver puts it down the same conventional method as if it were being fed by, again, six-wheeler or semi. Control panel on the back of the screen. So you're standing there. That overview is from the operator's position. That'll give you a good idea. Inside of the drum, if you haven't seen that, it's pretty exciting. There's the process unit itself. That's the first good picture I've seen. Thank you. So that would be the third oven deck in the front after the preheater. And then you have the mixing drum, and you can see all what's going on there. A pretty good looking mat, curb and gutter situation. That's the other thing. You don't have to worry about curb and gutter. We're putting back at the same height or elevation that this road was when it started. Put a roller on it. It's done. Nobody's coming to pay behind it. Nobody's going to put a micro or chip or anything else. Open the traffic. We're leaving this tied up a little bit more. I said in the heater scarification, the traffic's back on there immediately. We're going to hold people off for 5 or 10 minutes, but certainly no terrible interruption at all. There's a fun fact. every road's different, but we have kind of a standard application rate of around 1/10. There's a science here. There's methodology here. A back-end guy on any good recycling crew is going to dictate the application rate. Even if you take cores, you send them to the lab, and it says it looks like it's going to need this. This doesn't always come out that way. And it's usually a constant variation as they go down the road as well. We'll give it all we can. That's what we need to do. Prerequisites for HIR, as I think I said earlier, pavement has to be structurally sound, no base failures. That's not to say you can't go out and fix some, but we need the road is for the most part structurally sound, and those areas that aren't need to be fixed. And you need at least 3 inches of asphalt to work with. Types of asphalt pavements or candidates. Here's some pretty ugly looking roads. But again, everything's on a case-by-case basis. I'm not sure I agree with all these pictures, but if you have a contractor that's going to come look at entertaining the thought of doing some out-in-place recycling plant, have them come out and look at each road, take some cores, do some proper testing, so on and so forth. I don't think these are good candidates, and I think that's why that picture was put up there. I remember I was down south in southern part of the U.S. I won't identify the states, and I think I was looking for some roads. There's some roads. I think the verbiage I used was that there are some roads you can't do anything with, and I think both of these are pretty good examples of that. And then I have this picture there. I think that dog's a pretty good example of some roads you can't do anything with. But I was in this southern state, and I showed this picture, and nobody laughed. So I don't know if the dog's down that way or all that way. But there's a guy who's got some issues. He's got some problems. But anyhow, here's some typical roadways that for either process we're looking at. They have utility cuts, crack filler, cold patch, and there's also a pretty good picture of the before and after, the bottom center picture. That's a pretty good looking map. Here's some job pictures. These are heater scarification pictures up in Waukesha County, Wisconsin. Been a long time customer of ours. There's some good before and after. St. Louis, Missouri, good customer of ours, before and after. I think the purpose of that picture was to show they've got curb and gutter on that roadway that had already been paved into. They chose to leave it that way, so we heater scarified right into the curb line. But he did the curbside, and then he'll split that screed and crack just come down the center so we don't interrupt the crown, so on and so forth. That's a pretty good looking mat, but there again, that's going to get a surface treatment over it. There's some doctored airbrush photos to show you how good it looks. This is some actual pictures, a pretty good picture. Here's some out-in-place comparisons. Take a second to glance at that if you wish. Again, if someone has the interest or is more concerned, they know how to get a hold of us or ARA or any good contractor. But we've got some pretty extensive websites that are available. This just kind of very simply lays out the differences between the two processes. And it gives you a ballpark figure down there at the end. So what have we done? We've eliminated grinding, eliminated that intermediate or level course. We've eliminated a lot of trucking that goes with it. It's carbon footprint, I guess, is the buzzword today. So here's a list of Johnny good things that we've done. User delays, you just start talking about that and more, but we don't figure that into the equation, but it's very much part of the equation in my mind. I talked about that hard, early. Use what you've got, use what you own. I think that's Gallagher's milling machine when we're saying not to use it, then it's kind of a double-edged sword. Less carbon footprint. The heater scarification process, the reheat process, will reduce carbon footprint versus the alternative method which we're looking at now. And that includes the plant, the blending of virgin material, the trucking back and forth of the multiple layers, the milling machine, the trucking of that. The carbon footprint is reduced by 62%. That's huge. I always say that nobody's interested in go green, save green, do good for the environment unless there's a price tag attached to it, and that's just the God's honest truth. Recycling makes sense. but show me a saving, show me some money, show me what's in it for me, and then we can talk about the 62%. And we're about to show you that. There's quite a potential dollar savings in recycling. We have a copy of that. Someone would like to see it. Study published. It came up with the 62% numbers. And again, that's including the plant and everything that's involved in one methodology versus the other. Rejuvenator study of, no, I don't think that's available. If you want to see it, we can talk about it. But here's where I think you want to get to. These are the numbers. This is crunch time. Bear with it if the per ton asphalt price doesn't fit your area. I mean, we've got to plug in some numbers here. You head out on the East Coast, and it's up $90 upwards a ton. You come back in Southern Indiana, it may be down around 50. So we've got to take a stab at it. But this will show you some substantial savings with various methodologies and surface treatments. If you go from top to bottom, 28%, 26%, 23%, 53%. These are some huge numbers. Throw the 53 out. Throw the high and the low out. Look at the one in green at 26%. The 2-inch mill and fill versus a 1-inch with a 1-inch, an inch and a half hot in place recycle with a 1-inch overlay. 26% savings. That's huge. If someone walked in your office today and said, I can save you 26% and give you the same life expectancy on a product, you certainly wouldn't show them the door. 26% is, if your budget allows you this year to pave 10 miles and you have a 26% savings, now you're doing 12.6 miles. Let's look at your Pager rating system or whatever. It's not a Pager commercial either. Whatever rating system that you're using, which is why I threw that question out to begin with on the 1 to 100. But if you're using a Pager-like system, on a system 1 to 10, if you're doing if you're doing 10 miles every year, that's what your budget permits you to do. And now you utilize a resource like hot in place recycling, and now you're able to do 12.6. How long does it take you to raise that average Pager number or that rating, that pavement condition index number from 4.5 to 5 to 7 to 8.5 to 9 to being pretty respectable? It's the additional 2.5 miles a year that a process like this will allow you to get there, instead of wondering how it is that you're going to get there. Here's some, not all, but here's a handful of DOTs where hot in place recycling specification is in place. I may be talking to somebody from these states. I may be talking to nobody. That's what's so odd about this. I've got 2 guys here in the room with me. They're throwing stuff at me, so that's kind of fun. Makes me feel like I have a live audience here. I've got some job photos out here. This is heater scarification. This was last season down in Georgia. Rubber tired roller. Sometimes it appears, sometimes it doesn't. Depends on the specification. We can get good compaction and density with steel drum vibratory these days. And when you're traveling, if you don't have to have another piece of equipment, another operator, another fuel heater, just are not. If we're able to achieve and or meet customer expectations without. That's the emulsion. You see steam coming off the emulsion. You all know that emulsion is delivered by water. That's the steam cooking off of it. It's typically as smoky as we get. Got some other decks folded up there. Coming through a pretty high-end neighborhood. Steam. Pretty good looking matte finished product. Unfinished product that's going to get a surface treatment. I think it's a Georgia Union Worker Center was in this market. Typical roadway. Good hot in place recycling candidate, structurally sound. Good asphalt, good thickness mat, good thickness of the mat. Semi-finished product. crack filler you see there, it looks like she's bleeding a little bit. And ultimately hit that with the oven again, cut that right off. That's a pretty good looking mat before and after. Waukesha County, Wisconsin again. It's a pretty good looking mat. That's his new level course. That's not a finished surface course. That's his new level course. I said we continue to lower the bar. If you remember that performance curve I had before, 5, 6, 7 is textbook to do hot and place recycling. Well, this isn't 5, 6, 7. As I said, we continue to lower the bar. If you're on a 1 to 10 rating, if it was, again, I'm not a Pacer guy or whoever, on an index, pavement condition index, if you're on 1 to 10 rating, typically we were doing hot and place recycling, heater scarification down to the 5s, 5, 5.5, and over the last several seasons, we're down in the 4s now and 3.75. Again, it depends on customer expectations, but we continue to lower bar because the money is not there. They don't have an alternative. They're looking to build a bridge, and you have to do something to the roadway. Look at this roadway here, before and after. Same road, pretty good looking stuff. That looks like a finished mat, and that's going to receive, I think they'll put 3/4 of an inch overlay, ultra thin. Good looking mat. Manistee, Michigan, small community up on the lake on the west side of the state, regular customer of ours. It looks a little open grade there on the center line. I think we lost a roller there someplace. Must have gone for a drink of water, but we'll get that tightened up. There it is. Looks like you got a drink. Gonna have to make a third pass in that road, but that was the mayor of Manistee, Michigan. I think we're close to an hour. I think if I had to pull out some common denominators here, and that I started on the beginning with, is that I know you all have $100 worth of problems and $65 to fix it. You know what you've got out there on the roadway. You've got, for the most part, good aggregate that has oil on it. Don't be so fast to give that up. I mean, everybody says, "Oh, there's a ton of wrap laying around." There is a ton of wrap, but that's a valuable asset. You've got a pile of it out here that we will go through, we will use. It's valuable to us. I think it's valuable to you. So take a look at whatever discipline they are. The one I'm promoting today is hot and place recycling. About holding your program together, getting more miles for less money, getting some things done that you wouldn't be able to do otherwise. You have to think outside of the box in these particular times. This isn't the end all. I always tell people hot and place recycling is a size 10 shoe. I mean, road construction is a big shoe store. This is a size 10 shoe. And a good contractor is not going to want to put your size 8 foot in it or try to get your size 12 foot in. This is size 10. We're happy to come out and take a look at a guy's road, his inventory, or what's on the horizon for 2012, and see if he hasn't got a size 10 road out there. And if it's a good fit, structurally sound, got plenty of material, 3 inches of asphalt, it's good to go, and we meet your expectations. And this is a viable alternative to mill and fill that can save you a good amount of money. I think with that, I will conclude and figure out how we do questions. I don't know if you.
Okay, great. Thank you very much, Patrick. That was an excellent presentation. We do have a lot of questions coming in. First thing I want to do, though, is to share our survey, our poll results. The first question was on your roads under management, using a scale of 1 to 100, what is your average pavement condition index, or PCI rating? It looks like most of you on the call are in the 61 to 80 range. And the second poll question, with your typical annual road budget, what percentage of your total roads are you able to resurface? And the vast majority of you said less than 10%. And the final poll question that we asked was, other than milling, what forms of asphalt recycling have you used? It looks like almost half of you have not used any, and those of you who have mostly done the full depth reclamation. Some of the questions we had were similar. This one, how well does this work on pavement with the top surface being BST chip seal? Patrick,
that's a good question. I probably have to ask somebody that knew the answer. But typically, I'm not going to speak for the reheat process, for heater scarification. I'd say it's not so good for the reheat process. Heater scarification can handle a single lift of chip. Typically, you're looking at a road to repair a road. I'm sorry, Randy, did everyone hear that question through this note? Okay.
Absolutely.
Typically, you're looking at doing something on a chip seal road because most of the chips are gone and most of the seal is gone. So what seal remains, we will heat up, liquefy, and put back into the pavement as we will the rejuvenating agent. May actually use a little less rejuvenating. That's all positive. It's all good. But a single lift we can handle. Any more than that, you're looking for trouble. You're looking for smoke. You're looking for poor traction. We'd have to take a much closer look at it on the reheat method because, again, we're going to leave a finished surface course. But my thoughts are we haven't seen a lot of them. Is that a single lift or reheat rule, like it does for scarification, should apply for the reheat process as well.
We had the same question for other non-traditional asphalt pavements, rubberized concrete chips, heavy slurry seals. Anything different with those?
Yes. Depending on the amount that you have, rubberized crack filler is in fact rubber. And you put flame to rubber, it burns like tires. That's not to say, again, case-by-case basis, that's not to say that we wouldn't do it. But if we've got rubberized crack filler, it's going to be proactive on the contractor's part. He's going to have to mill that off, unless there's just a small amount of it. It seems every time I run into rubberized crack filler that the contractor that put it down is getting paid by the pound or the gallon because it's just small ski slopes on there. But in which case that's an issue for it. But it's certainly an issue that we can address.
And how does the process handle intersections with small radius curb returns?
Case-by-case basis. I'm not going to go back through and show these pictures out, but outside of the driving axle on most everything articulates and turns. These are live axles that have the capability of turning. We have some limitations. In older neighborhoods, for instance, cul-de-sacs are typically 78 feet wide. I can get about 2/3, maybe 3/4 of that. In the newer subdivisions that are over 100 foot, we can make that radius with either machine. Again, case-by-case basis. There are some instances with radius and returns that we can't get to. But knowing that up front, we can plan accordingly and make some alternate plans.
So can you make the statement that the structural number is the same for the 2-inch traditional mill pave and a 1-inch HIP plus a 1-inch overlay?
I'm very comfortable making that statement. The structural issue is coming from your surface treatment. I have changed nothing with either process to the mix design that was already there, whether it was 5 years ago or 15 years ago. So if you put out in Illinois, for an instance, an N50 mix, everybody has their own nomenclature. If you're putting out a surface treatment that is designed to give this set of circumstances roadway with easy loads and ADPs and so on and so forth, a 12 to 14-year life, if you had done hot in place instead of milling out and put that same N50 on the top, that's exactly what you will get. We have no problem talking about that all day long.
Okay. Is there a cure period for the rejuvenator before sealing the surface with a surface treatment like chip seal? And this viewer said it seems like there needs to be a wait.
Well, that's kind of a multifaceted question. If you are going to pave over this, if you pave within 48 or 72 hours, 1.5 inches over hot in place recycling, so you're talking the heater scarification method, you may well not need to use a tack course at all, certainly in 24 hours. As time goes on, you're certainly going to use less tack than you would normally, maybe even the light mist. After several days or a week or several weeks, you're going to require more and more. To put a chip seal on it, now that's putting an oil on an oil. You're probably going to wait a little bit longer and let the traffic / sun cook / beat that in a little bit before you go ahead and put that chip seal down, because it's a little different animal. That's why I said there's 2 questions in there. So,
okay. Can you adjust the width of the process?
Yes, we can. We get down to 8 feet, so we can do shoulders on arterials and feeders and interstates if we need to, and we get out to 15.5. The ovens as well as the screed. As I mentioned, it's a conventional paving screed on the back. So whatever the guy who paved your town last year or 5 years ago or whatever, look at his screed. Whatever his screeds can do, that's what's on the back of our machine.
So how do you work around the ironworks, the manhole covers, and so forth?
Well, I've got 2 processes that we talked about today. Very simply, the heater scarification process is spring-loaded tines, and they're spring-loaded for just that reason. You hit a manhole, a structure, B-box, whatever's in the roadway, they'll simply bounce over the top and go back to their prescribed depth, which again was 1.5 to 2 inches. With the reheat equipment, that has a moldboard that is gathering materials to take to the drum. And if I were able to go back here and pull some pictures up, which I'm not going to do, we have a moldboard that and a set of tines on it. So when we come into a structure area, we'll lift the moldboard so it doesn't take the top of the sewer off of it and go into forks and tines and agitate the material that way. So it's kind of a drawbridge. The moldboard's coming up and the tines are going down into the pavement. And as soon as they get over or past or by the structure, the tines will come back up and the moldboard will go right back down and resume its activities.
Okay. Can this process remove more than it puts back? For example, can it take 2 inches off and place 1 inch of the recycled asphalt back?
That's an interesting question. No. If I'm picking up 2 inches of material, it depends on the process, but I think both are no. I would love to chat with whoever put that question and to find out or discover exactly what he's trying to do. I think his pavement's too high and he needs to knock it down. And we could talk about that. This is probably not the answer to that problem.
Sure, and there will be a post the webinar survey that will come up after you log off the webinar, and you can ask Patrick any additional questions or give him your contact information and get back to you. Patrick, what's the life expectancy of these surfaces?
Well, again, we're talking about 2 processes. I think I identified in the presentation, if you will call it that given a 2-inch mill and fill versus hot and place recycling with the same mixed design, lift treatment or surface treatment on top, that you can expect whatever you were going to expect out of that total mill and fill you will get with hot and place heater scarification and recycling. I think it's a reasonable. The next generation, the reheat method, I have not been doing for 30 years. We have been watching roads before we constructed the equipment for, this will be 6 seasons now. We reheated a road that was side by side to a mill and fill. Both roads are degrading at about the same rate. So if I took you to these roads, you would not see the difference between the mill and fill side or the reheat 100% recycled side. So I think in the 6th year, it's safe for me to say that the life expectancy there will be about the same as well. I don't have any problem. We are achieving densities. We're getting all the tests back in a positive sense that we want. And I don't have any problem saying that process is going to give you the same expectation as well.
Okay, I've got another question here. What is an equivalent PG series on a type 3-inch HIR? I hope you understand what that means, Patrick.
No, but we got enough people around here that does. If again, not talking to an audience or saying, we just did a prototype project or a program project for the city of Chicago here not 10 days ago, and gave us a pretty ratty old worn-out road, and we did our testing on that road, and the gradation came back at a 6422. If that answers your questions, as well as passing an in-house Hamburg test here, which is geared mostly towards rutting.
Okay, well, thank you very much, Patrick. We've kind of run out of time, so we're going to end the webinar now, but you can certainly continue with the survey that we send. You can ask more questions. Patrick will be happy to get back to you. We're also going to be posting this recorded, this entire presentation